5-74 is an important exercise. So open your books, please, to 5-74. And read through the problem. And notice a couple of things. If you aren't activated to open up your textbook and take a look at 5-74, you aren't really participating in this assignment in the spirit it was designed in. Notice also that if you're watching this video on the little pop-up screen and not expanding it to full screen, you're also not participating in the manner this exercise was designed. So these are important exercises. Always be thinking about how you can adjust your process to get better results. This exercise is designed to remind you that the tools for right triangles are different than the tools for non-right triangles. Draw the triangle that's given in problem 5-74 with all of the information you have. And in A, you're asked to think of ways you can divide this triangle into two right triangles so that you can use right triangle tools to solve some of these problems. So this is one way that information can be delivered to you. In the larger triangle, we have two side lengths and an angle. In the smaller triangle, we have two angles and a side length. This triangle represents this piece right here. And this triangle is a right triangle. So there are some things you can do with this small triangle that will help you with the larger one. So it would be nice to know this value. It would be nice to know this value. So let's go ahead and use what we know about 30, 60, 90 triangles to find x and y. The short side is this side, the long leg, I should say the short leg is this leg, the long leg is this leg, the vertical leg. So we know, because this 30, 60, 90 is an exact copy of 1/2 of a 60, 60, 60, where all three sides have a length of 14. We know that this x represents half of one of those sides of 14, so this x is 7. We can use the Pythagorean theorem, or we can use the shortcut to show that y equals 7 times the square root of 3. Which leads us to another triangle. So the 7 square root 3 is a piece of information in two triangles now. We have a right triangle with one leg that is 7 square root 3. And we know that this piece of this triangle has a value of 7. but the long piece has a value of 20. So this distance that's left has a value of 13. Because 20 minus 7 equals 13. So we have a triangle with a leg that's 13, a leg that's 7 square root 3, and we can find out something about the hypotenuse using the Pythagorean theorem, or we could find theta using an inverse tangent function. So you have tools for each of these scenarios. It's really up to you to decide which one you prefer to use. The tangent of theta is 7 radical 3 over 13. So we can use the inverse tangent function because we know the ratio, and we can let our calculator look up the angle for us. If we had the angle, we could use it to finish the triangle. So go ahead and push those buttons for the inverse tangent. You're going to need to put 7 square root 3 in its own set of parentheses for the numerator of the ratio, and then close the parentheses after your denominator of 13. And we get a value for that angle of approximately 43 degrees. It's still a right triangle, so I'm going to find the hypotenuse using the Pythagorean theorem, and we can check it using the sine of 43 just to be sure. (49 times 3 plus 13 squared equals W squared. The square root of 316 is approximately 17.78. So we have a value for the long side, or the hypotenuse, of this piece of the triangle that corresponds to one of the legs of this triangle, the original triangle that we broke into 2 right triangles. And let's go ahead and use the sine of 43 to see if we get that same value. And you're pushing your calculator buttons each time. And this is a good opportunity to check yourself to see if you're able to use your calculator correctly. Some parentheses are involved in your numerator again, but you should be getting a value of 17.78 for the missing side. And based on this 60 and this 43, we can also find the missing angle. We have a 77-degree angle here that we simply are finding through the triangle sum theorem. And go go ahead and complete 5-75.
Look for your stand test.